In this video, we'll cover scatterplots, a popular type of chart to use when you have two continuous measures. I've got a Tableau workbook open, and we're already connected to the Atlanta flight delays dataset. We have a question that we want to answer in this video. What is the relationship between distance and airtime? Of course, we probably already know the relationship between these two fields, but it's a good example to show you how Tableau works. Intuitively, as we fly a longer distance, airtime will also increase. First, let's double-click on distance and then on airtime. We see a scatterplot with one mark, and this represents the sum of distance and the sum of airtime. We get aggregates for each of the fields because they're both measures. Instead of using sums across all flights, let's change these both to averages by using the drop-down caret in their pills. Go to Measure, and then Average. Do the same here. We can already see that our average distance across all flights in this data set is 668 miles. Also, average airtime is around 98 minutes. We usually want to see more than one mark in our scatter plot, and there are a couple of ways to do that. One way to add more marks is to change the level of detail. We do that by bringing another field into the view. Let's drag and drop the field called Dest for Destination Airport. Let's drop it onto Detail in the Marks card. In the status bar at the bottom, it shows us that we have 152 marks, or 152 airport destinations that are now on our plot. We see a close relationship between the two variables as we would expect. They follow a linear trend upwards. Longer distance flights have a longer airtime. Two marks are outliers, and you see them here. These are for flights to HNL Airport and OGG Airport. Both of those are airports in Hawaii. They have the longest haul domestic flights out of the Atlanta airport. We can also drag the field called Atlanta Delays Count onto Size in the Marks card. Recall that this is an automatically generated field that we can use to count the number of observations or rows in our data set. You can click on Size and you can increase or decrease the size of the marks with this size slider. Now we can see that those two destinations to Hawaii only represent a very small portion of the data. Using the tooltip, I can see that each of them have 3 delayed flights. You can also switch your axis by selecting the Swap Rows and Columns button in the top menu if you want to see it that way as well. I really like that feature. Sometimes it's easier to see a relationship between two measures by using even more marks. Let's go ahead and duplicate this worksheet. I'll do that by right-clicking and then duplicate. A second way to add more marks is by going to the Analysis menu up top on the toolbar and then unchecking this option for Aggregate Measures. This is often called disaggregating the data. Now we see each row of data, or every flight, plotted as a point. You can take your size and decrease it down to make those points a little smaller if you want to do that. The status bar shows that we have 5,244 marks, and that's because we have 5,244 rows of data, or flights, in our data source that we connected to. Next, let's create another new worksheet. We have another question that we want to answer, and this one isn't as clear to me what we'll find. We know that our top 2 categories of delay are for carrier delays and late aircraft delays. But what is the relationship between these two types of delays? This time we'll use a Show Me feature to build this scatter plot. Let's select both fields of interest, carrier delay and late aircraft delay. And then in the top right corner, let's use the Show Me tab and then select Scatter Plot. I see it here on my screen. Once again, you'll get aggregates for each of the fields because they're both measures. Let's disaggregate that data by going to the Analysis menu up top and unchecking Aggregate Measures. And now we see every flight plotted as a point. Here on the vertical axis for 0, We see from the information in the tooltip that these flights have carrier delays, but they have 0 aircraft delay. On the horizontal axis for 0, we see that these flights have aircraft delay, but not carrier delays. Any other points that are not on those axes are flights that have both types of delay. For example, this flight here that I'm hovering over had 791 minutes of carrier delay and 267 minutes of late aircraft delay. By default, Tableau includes information in the tooltip using all fields that you've used to create your viz. So that's why we see carrier delay and late aircraft delay in the tooltip as we hover. The really nice thing about tooltips is that it's very easy to add information to it. You can add more fields by dragging and dropping them into tooltips and marks. Let's take the main delay cause field. It's a dimension. And then let's drag and drop it into the tooltip icon in the marks card. Let's also drag and drop in the other types of delays, which are NAS delays, security delays, and weather delays into the tooltip. Look at the same flight again, and now we can see the main cause of delay has been coded as carrier delay in the data, and that's because the number of minutes of carrier delay is greater than the number of minutes of any of the other types of delay in the data. We can also add color. Let's take the main delay cause and drag it onto color in the marks card. I'll also change the drop-down option in the marks card from automatic to circle. You can click on categories in the legend and all the marks associated with it will be highlighted. This chart is helpful for understanding how the main delay cause field is coded in the data. It represents the largest cause of delay for a flight, but it doesn't necessarily mean that the flight did not also experience some of the other types of delay as well. This video has shown how scatterplots are helpful for revealing relationships between two continuous measures. Be sure to save your Tableau workbook.